The universe works here, and that might be the most dangerous assumption we have ever made. Everything you have ever learned about reality feels solid because it has never failed you. Gravity pulls things down. Time moves forward. Light travels at a constant speed. Cause comes before effect. Equations behave. Experiments repeat themselves. The universe, at least the part you live inside, feels obedient, predictable, almost polite. But what if that obedience is not universal? What if the laws of physics you trust so deeply are not laws at all, but habits? Local customs of a very small neighborhood in a much larger, stranger cosmos. Close your eyes for a moment and imagine something unsettling. Imagine that physics works here not because it must, but because this region of the universe happens to allow it. Imagine that beyond some invisible boundary, far beyond any telescope, beyond any signal we can receive, the rules quietly change. Not violently, not dramatically, just differently. This is not a story about broken science. It is a story about misplaced certainty. For centuries, humans have searched for universal laws. We wanted gravity to work everywhere, time to flow the same for all observers, light to obey the same limit in every corner of existence. We wanted a cosmos that plays by one rulebook, written once, applied forever. And so far, every experiment we have performed has agreed with us. Every experiment performed here. That word matters more than we admit. Here, in this region of space, here, at this temperature of the universe, here, at this age of cosmic history, here, inside this quiet pocket where matter clumps just enough, energy behaves just enough, and chaos stays politely in the background. We have mistaken consistency for universality. When Newton described gravity, he believed he had uncovered a force that governed apples and planets alike. When Einstein refined that picture, bending space and time themselves, we believed we had gone deeper, still closer to the ultimate structure of reality. When modern physics encoded the universe into equations of quantum fields and constants, we felt a quiet confidence settle in. This is how things work. But confidence is not proof of scope, it is proof of repetition. And repetition only tells you what happens where you are standing. Imagine a coastline you have never left. The tides rise and fall with perfect regularity. The water tastes the same every day. The waves break at familiar angles. After a lifetime there, you might conclude that all oceans behave this way. That water itself must follow these rhythms everywhere. Until you sail far enough, cosmology has given us a word that sounds technical but hides a deeply human limitation: the observable universe. It is not the whole universe. It is only the part from which light has had enough time to reach us. A sphere centered on Earth, expanding as time passes, bounded not by reality itself, but by the speed at which information travels. Everything we know about physics comes from inside that sphere. We have never tested gravity outside it. We have never measured time beyond it. We have never observed light behaving where our light cannot arrive. We call our laws universal because they work everywhere we have looked. But everywhere we have looked is astonishingly small compared to everything that might exist. This is where the discomfort begins to creep in. Because if the universe is not uniform, if it is divided into regions, zones, or phases where reality operates under slightly different rules, then our most cherished constants may not be constants at all. They may be local parameters, environmental settings, cosmic climate conditions. Gravity could be stronger elsewhere, or weaker. Time could flow unevenly, or not flow at all. Light might slow down, speed up, or fail to behave like a limit. Not because the universe is broken, but because it is diverse. Physics, in that case, would be less like a constitution and more like weather, stable for long periods, predictable within regions, and utterly different once you cross a boundary you cannot see. You might wonder why we have never noticed any sign of this. Why no telescope has caught the universe misbehaving. Why no observation has contradicted our equations. The answer may be simpler and more unsettling than we like. Because we live in a safe zone, a region of space-time where the rules happen to be smooth enough, gentle enough, and stable enough for complexity to arise. for atoms to form, for chemistry to persist, for life to emerge, for observers to exist who can ask these questions in the first place. We do not see broken physics, because broken physics may be unobservable to us. Regions where matter cannot clump, where time does not permit memory, or where causality dissolves may simply never send us signals we can understand, or any signals at all. Silence does not mean absence. It may mean incompatibility. Every telescope we build is calibrated for this version of reality. Every detector assumes that light behaves like light does here. Every equation assumes that time, space, and energy speak the same language across all distances. We are listening carefully, but only on one frequency. There is a quiet irony in this. The more precise our measurements become, the more confident we feel. Yet precision within a bubble does not tell you how large the bubble is. It only tells you that its interior is well behaved. Think of a snow globe. Shake it gently, and everything inside follows predictable paths. Gravity pulls the snow downward. Air resistance slows it. Patterns repeat. If you lived inside that globe, physics would seem complete. You would have no reason to suspect the glass. What if the universe has glass? What if beyond certain scales, or beyond certain energy thresholds, or beyond certain epochs of cosmic time, the equations we trust simply stop applying? Not abruptly, not with explosions or warnings, just with quiet failure. A calculation that no longer predicts, a constant that slowly drifts, a force that fades into something else. We already have hints, small, uncomfortable ones. Dark matter that refuses to behave like matter. Dark energy that accelerates expansion without explanation. Tiny discrepancies in measurements of cosmic expansion depending on how and where we look. We treat these as puzzles to be solved within our framework. But frameworks themselves can be local. There is something deeply human about assuming permanence. We build civilizations by trusting that tomorrow will resemble today. Science itself depends on that trust. Repeatability is its heartbeat. Yet the universe does not owe us emotional comfort. It does not owe us consistency beyond the conditions that allow us to exist. And here is where the thought becomes truly isolating. If physics only works here, if this calm, law-abiding region is a rare pocket in a vast and varied cosmos, then we are not standing at the center of universal truth. We are standing inside an exception, a fortunate one, a fragile one. We may be like deep-sea creatures living near a thermal vent, mistaking its warmth for the natural state of the ocean. Beyond the glow, the water may be lethal, or simply different in ways that make life as we know it impossible. This does not make our science wrong. It makes it provincial, and provincial knowledge can still be powerful. It can build machines, cure diseases, send probes to distant planets. But it must remain humble about where it applies. The universe may be vast, not just in size, but in behavior. If this idea unsettles you, that is a good sign. It means you are touching the edge of a belief you did not know you were holding. That reality itself is obligated to be uniform. It may not be. Before we go any further, let me pause here for something very simple and very direct. You are listening to Whispers of the Universe. If this kind of quiet, unsettling exploration matters to you, if you want more journeys like this into the edges of science and thought, please take a moment now to like this video, share it with someone who enjoys these questions, and subscribe to the channel. It is the clearest way to keep this space alive and growing. Now, return with me to the silence, because once you accept the possibility that physics is local, another question begins to surface softly at first, then with increasing weight. If these laws belong only to this region, what happens at the boundary? And how close might we already be without knowing it? Gravity feels like the most reliable thing in existence. You can close your eyes, let go of an object, and be certain of what will happen next. It will fall. Not sometimes, not usually, always, downward, with a quiet obedience that feels almost personal. Gravity has never surprised you. That familiarity has shaped how deeply you trust it. More than any equation or theory, gravity feels intuitive. You do not need mathematics to believe in it. Your body learned it before language, before memory, before doubt. And that is precisely why it may be the easiest law to misunderstand. Because gravity is not something we discovered everywhere. It is something we inferred from how matter behaves here, on Earth, in our solar system, in a thin slice of cosmic space where stars, planets, and observers can exist long enough to ask questions. We talk about gravity as if it were a universal command, a rule written into the fabric of existence itself. Mass attracts mass. Space-time curves. Objects follow the geometry laid out before them. But those statements quietly assume something we rarely acknowledge. They assume that space-time itself behaves the same everywhere. In our region of the universe, gravity has a certain strength. Not too weak, or matter would never clump into stars. Not too strong, or everything would collapse too quickly into black holes. It is balanced almost suspiciously so, balanced enough to allow complexity, chemistry, and eventually consciousness. This balance feels fundamental. But balance can also be environmental. On Earth, gravity feels constant because Earth is constant. Its mass does not change dramatically from moment to moment. Its structure is stable. But gravity on Earth is not the same as gravity on the Moon, or on Jupiter, or near a neutron star. We already accept that gravity varies with location. We just stop varying it after a certain scale. We assume that beyond stars and galaxies, gravity settles into a single, universal behavior. That space-time, once averaged over large distances, becomes smooth and uniform. Yet nothing in nature suggests that uniformity is guaranteed. Consider temperature. At small scales, temperature fluctuates wildly. At larger scales, it averages out. But only because energy can move freely and equilibrate. Only because the laws governing heat remain compatible across regions. If the deeper structure of space-time itself were different in different zones, if its elasticity, its dimensionality, or its responsiveness to mass varied, then gravity would not merely weaken or strengthen, it would change character. In some regions, mass might barely curve space at all. Matter would drift, unable to form stable structures. In others, space-time might be so responsive that even small masses create extreme curvature, tearing trajectories apart before complexity can emerge. From inside our calm region, gravity feels inevitable. From outside, it may feel optional. This leads to a quiet but profound shift in perspective. Gravity may not be a universal law in the sense we imagine. It may be a local expression of deeper rules that permit many outcomes, of which our version is just one. Think of language. The ability to communicate may be universal among intelligent beings, but the grammar is not. Word order, sounds, meanings all vary by region. From within one language, its rules feel natural, even logical. From outside, they are just one possible system among many. Gravity may be a dialect of space-time. We already know that gravity behaves strangely at extremes. Near black holes, time slows, space stretches, paths loop and fold. The familiar intuition breaks down, even though the equations still hold. That alone should warn us that gravity is not a simple force acting on a passive stage. It is an interaction shaped by the structure of reality itself, and structures can differ. Modern physics often speaks of symmetry, deep mathematical patterns that constrain how forces behave. But symmetry does not demand sameness everywhere. Crystals are symmetric, yet different regions can settle into different phases. Water follows universal rules. Yet ice, liquid, and vapor behave in radically different ways depending on conditions. Why should space-time be any different? If the early universe cooled unevenly, if inflation stretched some regions more than others, if quantum fluctuations froze into large-scale structure, then different cosmic neighborhoods could have settled into different gravitational regimes. Not broken, not chaotic, just distinct. In such a universe, gravity here would feel timeless and absolute because it has remained stable for billions of years. long enough for stars to form, burn, and die. Long enough for planets to circle quietly. Long enough for life to emerge and mistake stability for universality. But stability does not imply infinity. We do not notice gravity changing because, within this zone, it may not change at all. Or it may drift so slowly that no experiment we can perform would catch it. Our clocks, our rulers, our detectors are all made of matter that obeys the same local rules. If gravity shifted in lockstep with the structures used to measure it, the change would be invisible. It would feel like nothing happened. This is the most unsettling possibility of all. Not that gravity fails dramatically somewhere else, but that it fails quietly in ways that leave no trace within our observational bubble. We assume that if the universe were different elsewhere, we would see evidence of it at the edges. Strange distortions, broken patterns, anomalies too large to ignore. But what if the boundaries between cosmic zones are not sharp? What if gravity does not suddenly turn off or explode, but gently morphs, like climate changing, across latitudes? There is no single line where the tropics end and temperate zones begin. Only gradual shifts that become obvious only after you have traveled far enough. And far enough, cosmically speaking, may be unimaginably distant, beyond the reach of light, beyond the reach of time, beyond the reach of any question we can currently ask. From our perspective, gravity looks eternal because we are embedded within its comfort. We have built our entire understanding of motion, structure, and causality upon it. To imagine it as local feels like removing the floor beneath thought itself. Yet the universe has never shown concern for what feels comfortable to us. If gravity is a regional feature, then it is not the foundation of reality. It is a consequence of where we happen to be. A background condition that allowed complexity to arise, not a guarantee that complexity is possible everywhere. This realization introduces a new kind of isolation. Not just spatial isolation, but conceptual isolation. We may be unable to even imagine the physics beyond our zone, not because it is hidden, but because our minds evolved under rules that would not survive elsewhere. Gravity taught us how to think. It taught us that things fall, that structures persist, that causes have predictable effects. If those lessons are local, then our intuition itself is local. And as this thought settles, another law begins to feel less solid than it once did. Another certainty begins to blur at the edges. Because gravity is not the only thing we assume flows the same everywhere. Time, too, feels inevitable. And time may be even more regional than gravity ever was. Time feels even more trustworthy than gravity. You do not need to drop an object to believe in it. You are already inside it. Every breath confirms it. Every memory depends on it. Time moves forward, relentlessly, carrying you with it, whether you agree or not. At least, that is how it feels here. We talk about time as if it were a river flowing through the universe, the same everywhere, for everyone. A universal current that never stops, never turns back, never pools or dries up. Even when physics complicated that picture, introducing relativity, dilation, and warped clocks, we still held on to something familiar. Time might stretch, but it never breaks. It always exists. It always orders events. But that belief rests on the same quiet assumption as gravity. That time itself is a global feature of reality, not a local condition. Einstein showed us that time is not absolute. It slows near massive objects. It ticks differently for observers moving at different speeds. Two clocks can disagree about how much time has passed, and both can be correct. This was not philosophy. It was measurement. Satellites in orbit had to account for it, or their navigation systems would fail. Time already behaves differently, depending on where you are. We accepted this by expanding our equations, not by questioning time's universality. We adjusted the math and kept the comfort. Time may bend, we said, but it is still the same thing everywhere, just viewed from different angles. Yet relativity never promised that time must exist in all regions of the universe. It only described how time behaves where space-time itself has a familiar structure, and structure can change. Imagine a region where space-time does not permit a clean separation between past and future, where events are not ordered in a simple line, but arranged in loops, branches, or webs, where causality is not broken, but softened, less rigid, less directional. From inside such a region, memory might not function. Planning might not make sense. Identity itself could dissolve, not violently, but quietly, because the concept of before and after would lose its grip. Life, as we know it, would not arise there, and so we would never hear from it. This is the selection effect we rarely confront. We observe a universe compatible with observers because only such regions can be observed. We do not see the rest, not because it is absent, but because it is incompatible with seeing. Time feels universal because we exist where time behaves kindly. In our region, time flows smoothly enough to allow stars to burn steadily. Chemical reactions proceed at manageable rates. Information can be stored. Memories can form. Consciousness can stitch moments together into narratives. That may not be a cosmic default. It may be a privilege of location. There is a reason physicists struggle when they try to merge time with quantum mechanics. At the deepest level, time behaves strangely. In some formulations of quantum gravity, time disappears from the equations altogether. Not hidden, not distorted, simply absent. Events exist, relationships exist, but no universal clock ticks in the background. From our perspective, this feels impossible. How can anything happen without time? But that question assumes that happening itself requires the kind of time we experience. That assumption may be local. If time emerges from deeper processes, if it is not fundamental, but approximate, then it could emerge in some regions and not in others, or emerge differently, or fragment into multiple, incompatible flows. Our universe could be less like a single timeline and more like a patchwork of temporal environments, some regions flowing forward, some stalled, some looping, some so alien that the word time no longer applies. And just like with gravity, we would not notice. Our instruments rely on time. Our measurements are comparisons of intervals. Our experiments assume duration, sequence, repetition. If we tried to observe a region where time behaves differently, the signals might arrive scrambled, incoherent, or not at all. Not because the region is silent, but because we do not share its grammar. This leads to a deeply unsettling thought. The reason the universe appears calm, lawful, and predictable may not be because it is fundamentally so. It may be because chaos, inconsistency, and incompatibility filter themselves out long before they reach us. We are not seeing the whole universe. We are seeing the part that can talk to us, and talk to us in a language we understand. Gravity pulls, time flows, light travels at a constant speed. These may not be eternal truths. They may be regional agreements, conditions that happen to hold in this neighborhood of space-time, long enough for observers to evolve and mistake them for absolutes. If that is true, then the universe is not governed by a single set of laws. It is governed by layers, contexts, phases, each internally consistent but not globally uniform. And that means something quietly profound. When we say we are studying the laws of physics, we may actually be studying the laws of here. The rules of a safe zone, a habitable pocket, a region calm enough to think inside. Beyond it, reality may not break. It may simply stop making sense to us. And as this idea settles, one more certainty begins to feel less certain. Because even if gravity and time are local, there is one thing we believe connects everything, everywhere. Light, the messenger, the limit, the one constant we trust to carry truth across the universe. But what if light, too, is only fast? Here? And what would that mean for everything we think we know about what lies beyond our sight? Light feels like the last unbreakable promise. Even when gravity bends and time stretches, light remains our anchor. It travels, it carries information, it defines distance, it sets the speed limit of reality itself. Nothing, we say, can go faster. Nothing can escape it. Nothing can cheat it. Light is how the universe tells the truth. At least, that is what it feels like from here. Every image of the cosmos you have ever seen is made of light that arrived safely. Starlight that crossed millions or billions of years without losing its identity. Photons that behaved exactly as our equations predicted, obediently following paths through expanding space. Light has never lied to us. But that trust hides another assumption, one so deep we almost never name it. We assume that light behaves the same everywhere it exists. Not just here, not just nearby, but everywhere, always. We assume that the speed of light is not merely constant, but universal. That no matter where you go in the cosmos, light remains the ultimate courier of cause and effect. That reality itself is stitched together by the same luminous thread. Yet the constancy of light's speed has only ever been confirmed inside one region of spacetime. Inside the same calm neighborhood where gravity and time behave kindly. Inside the same bubble of observability that defines our entire scientific worldview. We have never clocked a photon beyond our horizon. Light, like gravity and time, has only been tested locally. This matters more than it sounds, because light is not just another phenomenon. It is the backbone of measurement itself. Distance is defined by how long light takes to travel. Time is synchronized by light signals. Even causality is structured around light cones' boundaries that separate what can influence what. If light's behavior were different elsewhere, then the entire architecture of reality would rearrange itself. In some regions, light might move slower. Information would crawl. Events would feel isolated, stretched apart, barely aware of one another. Structures might form differently, or not at all, because coordination across space would be too sluggish. In other regions, light might move faster. The universe becomes tightly coupled, restless, unable to settle into stable patterns. And in some regions, light as we know it might not exist at all. Not darkness, something stranger. Perhaps information is carried by other excitations, other fields, other messengers that do not behave like particles or waves in any familiar sense. Signals we could never detect, not because they are hidden, but because our instruments are blind to their mode of existence. From our perspective, such regions would look silent, empty, dark, but silence is not emptiness. It may be translation failure. We assume the universe is quiet beyond what we see because nothing answers back, but maybe we are calling out in the wrong medium, listening for light where light is no longer the language of reality. The idea of light as a universal speed limit comes from relativity, where it emerges naturally from the structure of spacetime. But relativity itself assumes a particular geometry, one that may not apply everywhere. If spacetime has phases, like matter does, then the rules governing light could shift across cosmic zones. Just as sound travels differently through air, water, or solid rock, information might propagate differently depending on the fabric it moves through. From inside our phase, light feels fundamental. From outside, it may feel incidental. There is an unsettling implication here. Every telescope we build assumes that light carries faithful information across space. Every observation assumes that photons arriving here have preserved the story of where they came from. But if light changes character across regions, if it slows, scatters, or transforms, then what reaches us may be filtered beyond recognition. We would not see the universe as it is. We would see the universe as light allows it to appear. And light may only be honest locally. This reframes a familiar concept in a disturbing way: the cosmic horizon. We often describe it as a boundary of time. Light from beyond it has not yet reached us. Given enough time, we assume it will. But that assumption depends on light behaving the same beyond the horizon as it does here. If the region beyond obeys different rules, then has not yet reached us, may quietly become cannot reach us at all. Not because the distance is too great, but because the language of signals changes. The universe could be filled with regions shouting in dialects we cannot hear. From inside our safe zone, this silence feels absolute. We build narratives of emptiness, of voids, of cosmic loneliness. We ask where everyone is, why no one answers, why the universe seems so vast and quiet. But perhaps the universe is not quiet. Perhaps it is speaking constantly, just not in light. If gravity taught us how matter gathers, and time taught us how events order themselves, light taught us how knowledge travels. It taught us that reality is something you can observe from afar, that truth can cross distance unchanged. If that lesson is local, then our entire notion of cosmic understanding is local too. We may be trapped not just in one region of space, but in one mode of knowing. And as this thought settles, another realization begins to form, slowly, uneasily. If gravity, time, and light can all vary by region, then the universe does not have one operating system. It has zones, cosmic environments with their own internal logic, their own stability, their own failures, which raises a question that feels less scientific and more existential. If we ever approached the edge of our zone, if our instruments reached far enough, or our theories pushed hard enough, would we recognize the boundary? Or would physics simply begin to stop making sense? One equation at a time? The idea of zones changes everything. It suggests that the universe is not governed by a single, uninterrupted logic, but by regions of agreement, vast territories where reality behaves coherently within itself, yet differently from its neighbors. Not chaos stitched together randomly, but a kind of cosmic geography. We are used to thinking this way on smaller scales. Earth has climates, oceans have currents, matter has phases. Ice, liquid, vapor each obeys the same underlying rules, yet behaves in radically different ways depending on conditions. What feels strange is extending that intuition to space-time itself, but nothing in physics forbids it. In fact, the early universe may have demanded it. When the universe was young, it was hot, dense, and unstable. Fields fluctuated. Symmetries broke. Energy settled into lower states. Not necessarily the same everywhere at once. Small quantum differences could have been stretched to cosmic scales during inflation, freezing local conditions into place. What emerged may not have been a uniform cosmos, but a patchwork. Different regions, born with slightly different settings, different values for constants, different relationships between space, time, and energy. Each internally consistent, each stable enough to persist, each unaware of the others. From inside one zone, the rules feel absolute. They do not change across planets or galaxies. They hold steady over billions of years. They allow prediction, repetition, trust. That stability is intoxicating. It encourages us to believe that what works here must work everywhere, that a single set of equations can describe all that exists, that the universe, at its core, prefers simplicity. But nature has never shown a preference for simplicity over abundance. It prefers what is possible. Cosmic zones offer a way to reconcile two facts that often feel at odds. On one hand, the universe appears remarkably fine-tuned for complexity. On the other, theoretical physics suggests that many different configurations of reality are mathematically allowed. Zones allow both to be true. Most configurations may be inhospitable, short-lived, or unable to support structure. A few rare zones like ours settle into conditions gentle enough for matter to organize, stars to burn steadily, and observers to arise. We do not see the others not because they are rare, but because we cannot exist within them. This reframes a question that has haunted cosmology for decades. Why do the constants of nature have the values they do? Why is gravity so weak? Why is the cosmological constant so small? Why does the universe expand at just the right rate to avoid rapid collapse or empty dilution? In a zoned universe, the answer is unsettlingly simple, because if they were different, we would not be here to ask. Our physics textbooks may describe the rules of our address, not the rules of reality itself. And there is another reason zones would remain hidden. Boundaries between cosmic regions may not be dramatic. They may not announce themselves with explosions or anomalies. They may be smooth transitions where one set of behaviors gradually gives way to another, too slowly to detect within a single lifetime or even a civilization's entire history. Just as a traveler crossing from one climate zone to another does not feel a sudden jolt, a probe drifting toward a cosmic boundary might not trigger alarms. Instruments calibrated to local physics would continue to function until they don't. And when they fail, the failure might not look like failure. Measurements could drift subtly. Constants could appear to vary. Equations would still produce numbers, but those numbers would stop matching reality in small, accumulating ways. Predictions would lose precision. Models would need patching. New terms would be added to compensate. From inside the zone, it would feel like a mystery to solve, not a border crossed. We already see hints of this pattern. Small discrepancies in cosmological measurements refuse to go away. Different methods of measuring the universe's expansion give slightly different answers. Certain observations align almost too well, while others resist reconciliation. Nothing breaks completely. Nothing screams contradiction. Reality just resists closure. We treat these tensions as signs of missing particles, undiscovered forces, or incomplete theories. And they may be, but they could also be something more structural. They could be the first whispers of geography, a reminder that the universe might not be one thing everywhere. If zones exist, then the phrase laws of physics becomes misleading. What we really mean is the operating conditions of this region, a local equilibrium that is held long enough to feel permanent. This introduces a subtle but profound shift in how we think about exploration. When we imagine reaching farther into space, we imagine more of the same. Distant galaxies, obeying familiar rules, new environments, but not new realities. We expect surprise in content, not in structure. Zones suggest the opposite. The greatest surprises may not be what we find, but how finding itself stops working. How observation becomes unreliable. How cause and effect loosen their grip. How signals refuse to translate. Beyond a certain distance, science might not fail spectacularly. It might simply grow quiet, less predictive, less certain, less comfortable, and we might misinterpret that silence as emptiness. This possibility casts a different light on cosmic isolation. The sense that we are alone, that the universe is vast, ancient, and strangely uninterested in contact. But isolation does not require emptiness. It only requires incompatibility. We may be surrounded by regions of reality that cannot touch us, not because they are far away, but because their rules do not intersect with ours in ways that allow exchange. We are not necessarily alone in the universe. We may simply be provincial. And as this thought lingers, another question begins to surface, quieter but sharper. If the universe is divided into zones, why do we never see the borders? What hides them so completely that even our most sensitive instruments return nothing but calm? We assume that if borders exist, we would see them. A line, a discontinuity, a place where equations fail loudly enough to demand attention. But the universe has never promised that its boundaries would be dramatic. On Earth, many borders are invisible unless you know how to look. Climate zones do not announce themselves with walls. Magnetic fields have edges you cannot see. Even the atmosphere fades gradually into space, molecule by molecule, until the idea of air quietly stops making sense. Cosmic borders, if they exist, would likely behave the same way. They would not be fences, they would be gradients. This is the first reason we do not see them. We are not equipped to recognize slow change when our reference frame changes with it. Every measurement we make is comparative. We compare lengths using rulers made of matter. We compare durations using clocks built from oscillations of energy. We compare forces using masses that themselves obey the same local rules we are trying to test. If the laws of physics were drifting gently, so gently that every measuring device drifted along with them, then nothing would appear wrong. Reality would change, and we would change with it. The second reason is more subtle and more isolating. Signals from beyond a boundary may not survive the crossing. Imagine sound traveling from air into water. Much of it reflects, some of it distorts. Only a fraction passes through, altered. Now, Imagine sound trying to cross into a medium where sound itself has no meaning. No compression, no wave. The silence you hear is not absence. It is incompatibility. If a cosmic zone operates under a different relationship between space, time, and information, then signals born there may not propagate into our region in a form we can receive, or they may arrive stripped of structure, flattened into noise, indistinguishable from randomness. From our perspective, nothing unusual happens. Telescopes see darkness. Detectors register background. Equations remain intact. The border hides itself by erasing its own evidence. There is a third reason we do not see the edge, and it is the most unsettling of all. We may be nowhere near it. Our observable universe feels vast, but on the scale of what might exist, it could be a small island, a stable plateau inside a much larger and more varied landscape. The distance to the nearest boundary could be so immense that even light traveling since the beginning of time has not reached it. In that case, the universe does not look uniform because it is uniform everywhere. It looks uniform because we are deep inside one zone. This creates a powerful illusion. From the center of a desert, sand looks endless. From the middle of an ocean, water feels infinite. Only when you approach the shore does variety reappear. But cosmology has no shorelines we can sail toward deliberately. We drift where expansion carries us. We look where light allows. We build theories inside a bubble whose size we cannot escape. And so we mistake depth for totality. Even more troubling is this possibility. What if boundaries are not fixed in space, but in condition? What if zones are not separated by distance, but by thresholds, by energy, by density, by scale? In that case, the edge is not out there. It is something you approach when you push physics far enough. At extreme energies, at extreme smallness, at extreme gravity. This would explain something physicists have quietly struggled with for decades. Why the closer we look at the foundations of reality, the less coherent our theories become. Why quantum mechanics and gravity refuse to merge cleanly. Why infinities appear where understanding should be deepest. Perhaps we are not discovering deeper layers of the same zone. Perhaps we are brushing against the conditions where our zone stops being valid. If so, the breakdowns in our equations are not flaws in our intelligence. They are warning signs, indicators that the language of this region is being stretched beyond its jurisdiction. Every time we force reality into a framework that no longer fits, we add patches, new terms, new particles, new assumptions. The math grows more complex, not because the universe demands it, but because we refuse to accept that simplicity may end at the boundary of our zone. And still, nothing announces itself as an edge. No alarms, no cosmic signposts, just a growing sense that something fundamental is being asked to behave outside its comfort. This is why the universe feels so eerily calm, not because it is simple, but because we are enclosed by conditions that have remained stable long enough for us to build civilizations, sciences, and stories that assume permanence. We live inside a long-lived pocket of consistency, and we have confused longevity with universality. The borders do not need to hide. They simply need to exist where we cannot go, see, or meaningfully measure. And as this realization settles, another uncomfortable thought emerges, one that shifts the question inward. If the universe is divided into zones, and if ours is unusually calm, what does that say about us? About our existence, our intelligence, and the kind of reality we are adapted to understand? That question does not point outward into space. It points inward, toward the limits of the mind that evolved here. Our minds were shaped here. That sentence sounds harmless, almost obvious. Of course, our minds evolved here on this planet, under this sky, within this version of physics. But the implication goes much deeper than biology. Our way of understanding reality is not neutral. It is adapted. Every intuition you have about how the world works was trained by a specific environment. Objects persist. Causes precede effects. Information travels reliably. Patterns repeat. These assumptions are not philosophical choices. They are survival tools. They worked here. In a region where gravity holds things together gently, where time flows smoothly enough to allow memory, where light carries information faithfully across space. Your brain did not evolve to understand reality in general. It evolved to understand this zone well enough to stay alive. This matters because when we do science, we are not observing the universe from the outside. We are interrogating it from inside a particular set of conditions, using minds that quietly assume those conditions everywhere. We notice inconsistencies only when they violate our expectations. But expectations themselves are local. Imagine a creature evolved in a world without sound. No vibrations, no pressure waves. If you tried to explain music to it, not by analogy but by direct description, language would fail, not because the creature lacks intelligence, but because its reality never demanded such a concept. There may be entire categories of physical behavior that our minds cannot easily grasp, not because they are complex, but because they never mattered here. This is the quiet trap of a calm universe. Stability breeds confidence. Confidence breeds assumption. Assumption hardens into certainty, and certainty becomes invisible. We rarely ask whether our deepest concepts, space, time, causality, identity, are universal. We treat them as the stage on which physics plays out, not as actors themselves. But those concepts may be part of the local scenery. If we lived in a region where time looped, we would not ask why time flows forward. If we lived where gravity repelled, we would not call attraction fundamental. If information did not travel cleanly, we would not build a worldview around observation at a distance. Our science reflects not just what the universe is, but what it allows us to notice. This reframes a familiar frustration in modern physics, the feeling that we are stuck. That progress slows as theories grow more abstract. That mathematics outruns intuition. That the deeper we go, the less reality feels anchored to anything we can picture. Perhaps we are not hitting a wall of complexity. Perhaps we are hitting the edge of cognitive compatibility. Our minds expect continuity. Zones may offer discontinuity. Our minds expect universality. Zones may offer plurality. Our minds expect translation. Zones may refuse it. And so, when physics begins to feel alien, we call it paradoxical. When equations lose intuitive meaning, we say reality is strange. But maybe reality is not strange at all. Maybe it is simply no longer ours. This introduces a humbling possibility. Even if we developed perfect instruments, flawless mathematics, and unlimited computational power, there might still be regions of the universe we cannot meaningfully understand. Not because they are hidden, but because understanding them would require ways of thinking that could not evolve here. Our intelligence may be a local adaptation, not a universal key. And that casts new light on a question we often ask with confidence: how far can science go? We imagine an ever-expanding horizon of knowledge, a steady march toward deeper truths. But horizons exist because of perspective. Move the observer, and the horizon moves too. What if some horizons are built into the zone itself? What if beyond a certain point, explanation dissolves, not into mystery, but into incompatibility, where asking why no longer applies because causality itself no longer behaves the way the question assumes? This does not make science futile. It makes it contextual. Science may be the art of understanding a region deeply, not the entire universe absolutely. And if that is true, then the most dangerous mistake we can make is not ignorance. It is overconfidence. Because once you believe your local truths are universal, you stop listening for anything else. You dismiss silence as emptiness. You interpret failure as error rather than signal. You assume that if something does not fit your framework, it must not exist. Zones, if they are real, do not announce themselves loudly. They wait for you to assume too much. And as this thought settles, another question quietly takes shape. One that shifts from what we can know to what we might encounter. If our minds are adapted to this zone, what would happen if we crossed into another? Would we recognize it as different? Or would reality simply begin to slip out of focus, one assumption at a time? We tend to imagine crossing into another region of the universe as a dramatic event, a boundary you pass through, a moment you can point to and say, "This is where it changed." But if zones exist, the transition may not feel like crossing a border at all. It may feel like losing clarity. At first, nothing obvious would break. Instruments would still return numbers. Equations would still produce results. Space would still look like space. Time would still tick on your clocks. Just not quite the way you expect. Measurements would begin to disagree with one another in subtle ways. Two methods that once converged would slowly drift apart. Constants would need ever smaller corrections. Predictions would work less often, and only after being carefully tuned. From the inside, this would look like complexity, like deeper physics, like unfinished theory. From the outside, it might look like disorientation, because crossing into another zone would not necessarily mean entering chaos. It would mean entering coherence of a different kind, a regime where the relationships you rely on no longer align cleanly with one another. Think of walking from land into the sea. At first, you are still upright. Your feet touch the ground. You can still breathe, but your movements become inefficient. Balance shifts. Familiar effort produces unfamiliar results. Nothing is broken. You are simply no longer optimized for the medium you are in. If a spacecraft drifted far enough toward a cosmic boundary, its instruments would not suddenly fail. They would begin to contradict each other. A clock would disagree with a ruler. A signal would arrive on time but carry the wrong structure. Energy would seem conserved in one calculation and not in another. Engineers would respond the only way they know how. They would recalibrate. And recalibration is a dangerous comfort. It allows you to believe that reality is still fundamentally the same, just mismeasured. It postpones the realization that the underlying assumptions may no longer apply. We already do this. When physics misbehaves at extreme scales, we do not ask whether the zone has changed. We assume we need new particles, new fields, new symmetries, extensions of the same framework. We add layers rather than question foundations, because questioning foundations feels like giving up ground. But imagine a moment when recalibration no longer works, when no single adjustment fixes the inconsistencies, when every correction solves one problem and creates another, when theory begins to sprawl, not toward unity, but toward fragility. At that point, you would not feel like you had discovered something new. You would feel like you were losing something old. Clarity, confidence, the sense that reality wants to be understood. This is why crossing into another zone might never be recognized as such. There would be no announcement, only a gradual erosion of predictability, a sense that the universe is becoming less cooperative. From inside the zone, it would feel like failure. From outside, it might look like adaptation, because another zone would have its own internal consistency, its own regularities, its own stable patterns. But those patterns would not map cleanly onto ours. To understand them, you would need new intuitions, not just new equations. And intuition is not something you can upload. This raises a deeply unsettling implication for exploration. We imagine sending probes farther and farther, confident that more data will always mean more understanding. But data only becomes knowledge when it fits a conceptual framework. If the framework itself is local, then more data may simply deepen confusion. At some point, exploration may stop being additive. It may become subtractive. You would have to let go of assumptions that once felt self-evident. You would have to accept that concepts like distance, duration, and even existence may not survive intact across zones. And that is not a technical challenge. It is a psychological one, because humans do not like letting go of the ideas that made them successful. Our entire scientific history has been built on the assumption that deeper reality is more unified, not more fragmented. That beneath apparent complexity lies a simpler truth. Zones suggest the opposite direction. That beneath apparent unity lies diversity. Not disorder, not randomness, but difference. And difference is harder to master than simplicity. If this is true, then the universe is not hiding its secrets behind distance alone. It is hiding them behind compatibility. You can only understand a region of reality if you share enough of its rules to think inside it. That may be why the universe feels so quiet beyond our horizon. Not because nothing is there, but because what is there cannot meet us halfway. And as this thought settles, another realization begins to form, one that shifts the focus from exploration to existence itself. If zones select for certain kinds of behavior, and if ours selects for stability, memory, and slow change, then our presence here may not be accidental at all. It may be inevitable, which raises the next question, quietly and insistently. Are we here because this zone is special? Or does this zone feel special because we are here to notice it? We often speak about the universe as if it were designed to be understood, not designed in a religious sense, but in a quieter, scientific one. As if reality itself prefers elegance. As if equations exist because the universe wants to be legible. As if truth is something that naturally reveals itself to any intelligence patient enough to look. This belief is rarely stated outright, but it hides beneath our confidence. We celebrate the fact that mathematics describes nature so well. We marvel at how abstract symbols written on paper can predict the motion of planets, the behavior of particles, the bending of light. We take this resonance between mind and cosmos as evidence that we are uncovering something fundamental, but there is another way to see it. What if the reason the universe feels understandable is not because it is universally ordered, but because we exist only where understanding is possible? In a zoned universe, this distinction matters. If most regions of reality are unstable, incoherent, or hostile to long-lived structure, then intelligence would never arise there. No observers, no questions, no equations. Those regions would remain unremarked, not because they are empty, but because they are uninhabitable to thought itself. We would never hear from them. The regions that do allow observers would share certain traits: regularity, persistence, reliable cause and effect, information that travels without dissolving, time that flows smoothly enough to support memory. From inside such a region, the universe would feel remarkably well-behaved, not because it is universally so, but because only well-behaved regions can be noticed. This is the quiet circularity we rarely confront. We observe a universe compatible with observation. We build theories suited to that compatibility. Then we marvel at how perfectly the universe fits our theories. But fit does not imply intention. It implies selection. We are not seeing the universe as it is everywhere. We are seeing the universe as it must be here for us to exist at all. This does not diminish science. It reframes it. Science becomes the study of a habitable zone of reality. Not just a habitable planet, not just a habitable galaxy, but a habitable physics. This helps explain why the universe feels finely tuned without requiring that it be tuned for us. If zones exist, then most configurations simply never produce observers. A few rare ones do. Those observers inevitably find themselves in regions where the rules feel elegant, stable, and almost welcoming. From their perspective, the universe feels special. From a broader perspective, it may be merely survivable. This thought carries a subtle emotional shift. It replaces cosmic centrality with cosmic coincidence. We are not at the center of reality. We are at the center of our own compatibility. The universe did not arrange itself so that minds could understand it. Minds arose where understanding was possible. And once they did, they mistook possibility for purpose. This mistake echoes everywhere in our thinking. We assume that if something is deeply meaningful to us, it must be deeply meaningful to the universe. We assume that if laws feel elegant, elegance must be fundamental. But elegance may be local aesthetics. Our mathematics evolved to compress patterns efficiently. Our intuitions evolved to predict outcomes in this environment. We call the resulting harmony truth, but it may be closer to resonance. A resonance between a certain kind of mind and a certain kind of region. If that is the case, then beyond our zone may lie realities that are no less real, but far less resonant. regions where patterns do not compress neatly, where prediction is expensive, where stability is fleeting, where meaning does not accumulate, not broken worlds, just worlds that never invite understanding. This may explain why the universe feels ancient yet patient, vast yet oddly quiet, full of structure yet resistant to final explanation. We are not uncovering the universe's ultimate nature. We are uncovering the nature of the place where uncovering can happen. And that realization leads to a question that feels both humbling and unsettling. If intelligence arises only in certain zones, and if those zones naturally encourage the illusion of universality, how many civilizations, scattered across the cosmos, have reached the same conclusion we have? How many have believed, with complete sincerity, that they finally understood reality, when in truth they had only mapped their neighborhood? And if they did any of them ever realize the difference? There is a particular kind of comfort in numbers. They feel indifferent to belief, immune to interpretation. A constant is a constant, we tell ourselves, because it does not care who measures it. It simply is. The speed of light, the strength of gravity, the charge of an electron, fixed anchors in a sea of change. We trust these values more than any story, because stories can be wrong. Numbers feel eternal, yet every constant we have ever measured has been measured here. Not metaphorically here, literally here, inside the same zone of space-time, under the same conditions of expansion, with instruments built from the same matter, obeying the same local rules. We call them fundamental constants, but what we really mean is locally stable parameters. This distinction is easy to ignore when values remain unchanged across every experiment we can perform. When decades pass and numbers stay loyal, constancy begins to feel like proof of universality. But constancy over distance is not constancy over reality. Imagine measuring the boiling point of water without ever leaving sea level. You could repeat the experiment endlessly and obtain the same result. You might conclude that the boiling point is a property of water itself, not of pressure. You would be wrong, but consistently so. Only by leaving your region would the illusion break. Cosmic constants may hide the same trap. In theoretical physics, there is nothing sacred about the numerical values we observe. Many theories allow a vast range of possibilities. Slightly stronger gravity, slightly faster expansion, slightly different ratios between forces. Most of these configurations produce universes that are short-lived, structureless, or hostile to complexity. A few do not. We live in one of the few that didn't self-destruct. From inside such a universe, constants feel miraculous, perfectly tuned, balanced on a knife's edge. We debate whether this tuning requires explanation, design, or deeper necessity. But in a zoned universe, tuning may be a selection effect. Different regions settle into different values. Most fade quickly. A handful persist. Observers arise only in those handful, and those observers, inevitably, find the constants astonishingly well suited to their existence. Not because the universe was tuned for them, but because they could only exist where tuning occurred. What we call constants may be environmental variables, cosmic temperature, vacuum energy, the stiffness of space-time, the way fields settle into ground states. All of these could vary from zone to zone without violating any deeper principle. They would simply reflect different initial conditions, frozen into place by cosmic history. From our vantage point, such variation would be invisible. We cannot step outside our zone to compare. We cannot rerun the universe with different settings. We have only one sample, and we are inside it. This is a dangerous position from which to generalize. When physicists speak of the universe as if it has chosen these constants, they are often expressing awe. But awe can disguise assumption. The assumption that there was a choice at all, rather than a distribution. Zones dissolve that assumption. They suggest a universe that explores possibilities not sequentially, but spatially. Not through time, but through coexistence. Different realities operating side by side, separated not by walls, but by incompatibility. In such a cosmos, the phrase, "Why this value?" loses its force. The answer becomes simple, almost cold. Because this value survived here, and survival, not necessity, may be the deepest principle at work. This idea reshapes how we interpret anomalies. When a measurement hints that a constant might vary over cosmic time or distance, we rush to explain it away. Systematic error, instrument bias, statistical fluke, because the alternative is unsettling. It suggests that the numbers we trust may be stable only within a domain, that outside it, the universe may be running on different settings entirely. Not wrong settings, just different ones. If constants vary by zone, then physics is not a single script, but a family of scripts, related, constrained, but not identical. Each one consistent within itself, none of them privileged across all of reality. Our equations would still be correct. They would just be incomplete. They would describe this zone with exquisite accuracy while remaining silent about others. And silence, once again, would not mean absence. It would mean that our mathematics has reached the edge of its jurisdiction. As this thought settles, another realization begins to take shape, one that feels less abstract and more personal. If the numbers we trust are local, if the constants we rely on are environmental, then everything built upon them, stars, chemistry, biology, consciousness becomes local too. We are not just inhabitants of a place in space. We are inhabitants of a particular version of reality. And that raises a question that feels impossible to avoid. If reality comes in versions, what happens to meaning when you realize yours is only one of many? Equations feel like the most honest things we have ever made. They do not persuade. They do not comfort. They do not care who believes in them. When an equation works, it works silently, relentlessly, without emotion. It predicts eclipses centuries in advance. It lands probes on distant worlds. It tells us where a particle will be found before we look. So, when equations stop working, we take it personally. We assume the failure is ours, a missing term, a hidden variable, an approximation pushed too far. We rarely consider the possibility that the equation is doing exactly what it should, refusing to operate outside the region it was born to describe. Because equations, like minds, are local achievements. Every fundamental equation in physics was distilled from patterns observed here. Motion under this gravity, fields in this space-time, energy behaving under these constraints. We abstracted, generalized, and formalized, but always within the same underlying environment. The math feels universal because the environment has been stable. But stability can mask jurisdiction. Think of a map drawn with perfect accuracy for a single continent. Roads, rivers, elevations, cities, all captured flawlessly. For generations, the map works. Travelers trust it. Engineers rely on it. No one questions its completeness until someone sails far enough. At that point, the map does not tear. It does not announce its limits. It simply stops corresponding to what is there. Land appears where ocean was expected. Coastlines curve where none were drawn. The map still makes sense internally, but the world has moved beyond it. Physics may be approaching that moment. At extreme energies, equations produce infinities instead of answers. At the smallest scales, space and time refuse to behave like continua. When gravity and quantum mechanics are forced to speak to each other, their languages clash, not violently, but irreconcilably. We call this the frontier of knowledge. But frontiers are not always where things are unknown. Sometimes they are where known tools no longer apply. We respond by inventing deeper theories. String theory, loop, quantum gravity, extra dimensions. Mathematical landscapes vast enough to contain every possibility. These efforts are not failures. They are honest attempts to extend the map. Yet notice something subtle. As theories grow deeper, they also grow less testable, less anchored to observation, more dependent on internal consistency than empirical confirmation. This is often framed as a temporary limitation of technology, But what if it is a structural one? What if equations derived in this zone cannot fully describe realities outside it, not because they are wrong, but because they are incomplete by design? In a zoned universe, equations do not fail catastrophically at boundaries. They lose relevance gradually. They predict trends but miss details. They conserve quantities approximately, but not exactly. They remain elegant but stop being decisive. From inside the zone, this looks like mystery. From outside, it might look like clarity, because another zone would have its own equations, its own regularities, its own forms of mathematical compression that feel just as inevitable to minds that evolved there. We often assume that mathematics itself is universal, that any intelligence, anywhere, would discover the same structures. But mathematics is also shaped by what it tries to describe. Counting emerges where discrete objects matter. Geometry emerges where space behaves smoothly. Calculus emerges where change is continuous. If reality behaves differently elsewhere, the mathematics that resonates with it may be different too. Our equations feel profound because they align with the deep structure of this region. They may feel trivial or misleading elsewhere. This introduces a humbling reinterpretation of progress. We are not climbing toward a final theory that explains everything. We may be refining a regional theory to exquisite precision, perfecting our understanding of one valley while mistaking it for the entire landscape. And the more precise we become, the easier it is to believe that nothing lies beyond. Precision breeds confidence. Confidence breeds closure. But closure may be premature. When equations begin to feel strained, when constants must be tuned, when new layers are added to preserve old assumptions, it may not be because reality is stubborn. It may be because we are asking regional tools to do global work. The universe may not be resisting understanding. It may be politely declining translation. And as this thought settles, another realization begins to surface, one that turns the question back toward the future. If equations lose power as we approach the edges of our zone, if prediction becomes fragile instead of firm, then how far can we really go before certainty dissolves? And what will we mistake that dissolution for? Ignorance, or the first sign that we have reached the limits of where this version of reality applies? There is a quiet comfort in believing that what works now will always work. It allows civilizations to plan. It allows science to accumulate. It allows meaning to feel stable instead of provisional. When laws appear eternal, existence feels anchored. The future may be uncertain, but the structure beneath it feels fixed. Gravity will still pull. Time will still pass. Light will still connect distant things. The universe may change, but not that much. This belief is not foolish. It is practical. Civilizations cannot function if they constantly question the ground beneath them. Science itself depends on trust. Trust that experiments performed tomorrow will resemble experiments performed today. That nature will answer the same questions with the same replies. But practicality can quietly become dogma. At some point, the assumption that laws are universal stops being a working hypothesis and becomes an emotional necessity. We do not just rely on it. We need it. It becomes part of how we manage uncertainty, mortality, and scale. The universe feels less threatening when it is governed by rules that do not change. Zones disrupt that comfort. They suggest that stability is not guaranteed everywhere, that permanence may be regional, that the calm we experience could be temporary on cosmic scales, even if it lasts longer than civilizations, species, or stars. From inside a long-lived zone, this is easy to ignore. Billions of years pass without noticeable change. Constants hold. Patterns repeat. The absence of disruption becomes evidence of eternity. But absence of evidence is not evidence of absence, especially when the thing you are missing lies beyond the conditions required to observe it. There is something psychologically powerful about mistaking endurance for universality. The longer something lasts, the more deeply we trust it. The more deeply we trust it, the harder it becomes to imagine alternatives. This is why the idea of zones feels destabilizing. It suggests that the universe is not obligated to preserve the conditions that allowed us to arise, that the rules we rely on are not promises, but circumstances. That reality does not bend to protect understanding. We often speak of cosmic disasters, asteroid impacts, stellar explosions, vacuum decay as threats to existence. But those threats operate within our zone. They respect the same laws, even as they destroy. Zones introduce a different kind of vulnerability. Not destruction, but invalidation. A scenario where the rules themselves change not abruptly, not catastrophically, but enough that familiar processes no longer function as expected. Where chemistry still exists, but differently. Where energy still flows, but not in ways we can harness. Where time still passes, but not in a direction that supports memory or planning. From our perspective, this feels like the end of meaning. Because meaning, like science, relies on continuity. Continuity of cause and effect. Continuity of identity. Continuity of explanation. If zones exist, continuity is not a universal guarantee. It is a local privilege. This does not mean the universe is hostile. It means it is indifferent. Indifference is harder to negotiate than hostility. An enemy can be understood. Indifference offers no leverage. And so we cling to universality, not just because it has worked so far, but because it offers emotional stability. It tells us that reality is fundamentally the same everywhere, that truth discovered here applies everywhere, that understanding is transferable. Zones threaten that story. They suggest that truth may be contextual, that explanations have domains. That understanding does not automatically scale with distance or depth. From this perspective, the history of science takes on a different tone, not a march toward absolute truth, but a deepening intimacy with a particular environment. A refinement of tools suited to one set of conditions. We are not wrong to do this, but we are wrong to assume it is everything. The danger is subtle. It is not that science fails. It is that science succeeds so well locally that it blinds us to its boundaries. The better our predictions become, the more tempting it is to believe that no boundaries exist. This is how confidence turns into complacency. And complacency is invisible until it breaks. If zones are real, then the universe may not end with a final theory. It may end, for us, with diminishing returns, with explanations that grow longer and less illuminating, with answers that solve problems without increasing understanding. Not because reality is exhausted, but because we have reached the limits of what this zone allows us to grasp. And as this thought settles, one final layer of discomfort emerges. If stability is local, if laws endure here but not everywhere, then the question is no longer whether the universe will change. It is whether we are prepared to recognize change when it arrives quietly, without announcing itself as an ending. Civilizations do not arise in hostile physics. They arise where the universe is patient, where stars burn long enough to seed planets, where chemistry has time to explore complexity, where energy gradients persist instead of collapsing instantly, where memory can form and information can be preserved. In a zoned universe, this is not a coincidence. It is a filter. Only certain regions allow anything like history to unfold. Only there can cause and effect stretch far enough apart to be noticed. Only there can patterns repeat long enough to be learned. Only there can intelligence emerge and mistake endurance for inevitability. We did not just evolve on a stable planet. We evolved inside a stable physics. That fact quietly shapes everything we call progress. We build civilizations by stacking assumptions. Assumptions about materials, energy, predictability, and scale. We assume that bridges will hold, that machines will repeat their behavior, that signals will arrive intact, that tomorrow will resemble today closely enough to plan for it. None of this is guaranteed by existence itself. It is guaranteed only by where we are. From inside a long-lived zone, civilization feels natural, almost expected. We speak of intelligence as something the universe produces, as if complexity were an inherent tendency of reality. But complexity is fragile. It requires narrow conditions. It requires stability without stagnation. It requires rules that are strict enough to be reliable, yet flexible enough to allow novelty. Most regions of a zoned universe may never satisfy that balance. They may burn too fast, drift too slowly, or fluctuate too violently. No stories begin there. No histories accumulate. Nothing notices itself existing. Those regions leave no record. So, when we look out and see a universe that seems strangely empty, we may be misreading the silence. We may be surrounded by vast expanses where reality unfolds too quickly, too slowly, or too inconsistently to host observers. From our position, existence feels rare but intelligible. From a wider perspective, intelligibility itself may be rare. This reframes the idea of cosmic loneliness. We often ask why the universe appears so quiet, why we do not see signs of other civilizations. We imagine technological limits, self-destruction, or the improbability of life. Zones offer another possibility. Civilizations may arise only in a small subset of regions, and those regions may be isolated not by distance, but by physics. Even if another civilization exists relatively nearby in cosmic terms, incompatible rules could prevent any exchange of information. They may be shouting, we may be listening, but the medium does not carry the message. Our own civilization may be confined not by light years, but by compatibility. This confinement shapes ambition in subtle ways. We dream of exploration, expansion, mastery. We imagine spreading through the galaxy, carrying our understanding with us. We assume that more distance means more of the same, just farther away. But if zones exist, expansion is not just a matter of propulsion. It is a matter of adaptation. A civilization optimized for one set of physical rules may not survive in another. Not because it is weak, but because its technologies, biology, and assumptions are tuned to a specific environment. The farther it travels, the more likely it is to encounter conditions where its strengths become liabilities. This does not mean civilizations cannot cross zones. It means crossing may not look like conquest or discovery. It may look like transformation, a shedding of old certainties, a gradual loss of familiar functionality, a redefinition of what it means to exist at all. From inside a safe zone, such a future is almost impossible to imagine. We picture continuity. We project ourselves forward, unchanged, carrying our laws and logic intact. But continuity may be another local privilege. The universe did not promise to preserve our kind of civilization beyond the conditions that created it. And that realization leads to a quiet, unsettling thought. If our civilization is a product of this zone, and if zones are temporary or bounded, then civilization itself may be a transient phenomenon. Not because intelligence fails, but because the environments that support it are rare, isolated, and finite. We may not be participants in a grand, universal story of progress. We may be a chapter written by one calm region of reality, lasting just long enough to notice itself. And as that thought lingers, another question begins to form, one that points not to our origins, but to our future. If zones define what kinds of civilizations can exist, what happens when a civilization begins to push against the limits of its own zone? The universe may not be silent. It may simply be speaking in ways we cannot receive. For decades, we have searched the sky for signals. Narrow bands of radio waves, repeating patterns, artificial rhythms carved into cosmic noise. We listen patiently, convinced that if intelligence exists elsewhere, it will announce itself in a language we recognize. Light, radio, mathematical regularity. These are the messengers we trust. But those choices reveal more about us than about the universe. We assume that any intelligence, anywhere, will communicate the way we do by modulating signals that travel cleanly through space and time. We assume that information must propagate in a form compatible with our detectors. We assume that meaning survives distance intact. Those assumptions hold here. They may not hold elsewhere. In a zoned universe, communication is not just about intent. It is about compatibility. Two regions may both host complexity, structure, even intelligence, and still be completely unable to exchange information. Not because they are far apart, but because the carriers of information differ. Imagine trying to communicate across a boundary where light no longer behaves like light, where signals do not preserve phase, where causality itself is organized differently. Any message crossing such a boundary could arrive scrambled, diluted, or stripped of the structure that made it meaningful. From our side, it would look like noise. We would scan the sky, see nothing unusual, and conclude that no one is there. This may explain a haunting feature of our observations. The universe does not just lack clear signals. It lacks almost signals. Near misses, ambiguous artifacts, messages that nearly make sense but never quite do. Silence is easy to explain. Near silence is harder. Zones offer a reason. Signals born in other regions may reach us only after being filtered through incompatible physics. They arrive not as messages, but as background. As irregular fluctuations, as anomalies too messy to interpret and too consistent to dismiss. We may already be receiving them and mistaking them for nothing. This possibility reframes the search for intelligence in a deeply unsettling way. It suggests that the failure to detect others is not evidence of rarity or extinction, but of translation failure, a mismatch between how reality carries information here and how it does elsewhere. We are listening carefully, but only in our own language. Even worse, the most stable, communicative regions may be the rarest ones. Zones like ours, where signals propagate cleanly, time flows smoothly, and information remains coherent over vast distances, may be cosmic exceptions. Civilizations arising in other zones might never develop astronomy, never look outward, never conceive of distant observation. Their reality may not allow it. From our perspective, they do not exist. From theirs, neither do we. This creates a chilling symmetry. Each zone may be filled with observers who believe they are alone, not because the universe is empty, but because it is partitioned. The silence between zones is not empty space. It is a failure of contact, and this failure would be complete. No gradual hint, no partial message, no shared reference frame, just the steady conviction, on all sides, that no one else is there. This may be why the universe feels so vast and indifferent, not because it lacks life, but because life is compartmentalized, each pocket sealed by the very rules that make it possible. We often imagine first contact as a moment of discovery, a signal detected, a pattern recognized, a confirmation that we are not alone. But in a zoned universe, first contact may never happen, not because civilizations do not exist, but because reality does not permit overlap, and that leads to a quiet, unsettling thought. If signals cannot cross zones, if information itself is local, then observation becomes a deeply biased act. We do not see what is there. We see what our region allows us to see, which means that the universe we believe we inhabit may be only a thin slice of what exists, carefully curated by compatibility, stability, and silence. And as this realization settles, another question begins to surface. If signals cannot cross zones easily, what about influence? What about effects that do not travel as messages, but as consequences? Could other regions shape our universe without ever being seen, leaving fingerprints we misinterpret as randomness, or fate, or dark unknowns we give new names to, simply because we cannot trace them back to their source? Not all influence needs a message. We tend to imagine causality as something that travels neatly, packaged in signals we can trace. A photon leaves a star. A wave crosses space. A force reaches out and pulls. Cause, then effect. Source, then consequence. That picture works here, but it may only work here. In a zoned universe, regions do not need to talk to affect one another. They only need to coexist. Consider pressure. One region of air does not signal another. It pushes. Consider gravity itself. Mass does not broadcast instructions. It shapes the geometry around it, and everything else responds. Influence does not always arrive with a label. If zones exist side by side, separated not by walls, but by transitions in physical behavior, then effects could leak across boundaries even when information cannot. Not as messages, but as constraints. Not as communication, but as influence without explanation. From our perspective, such effects would appear originless, Something pulls without a visible source. Something accelerates without a detectable cause. Something shapes large-scale behavior without emitting signals we can trace. We already have names for these things: dark matter, dark energy. We speak of them as if they were substances, entities waiting to be discovered. But what if they are not things at all? What if they are boundary effects, consequences of neighboring zones whose internal logic we cannot access, but whose presence still warps ours? In that case, we are not missing particles. We are missing context. Imagine standing on a flexible surface while something heavy rests just beyond your field of view. You never see the object. No light reflects from it into your eyes. But the surface curves, your paths bend, your measurements change. You invent a name for the curvature. You do not know what caused it. From inside one zone, the influence of another would look exactly like this: real, measurable, persistent, and utterly disconnected from any observable source. We assume that if something affects us, we should be able to observe it directly. That assumption is another local habit. Influence does not require legibility. If space-time itself has phases, then the behavior of one phase could shape the geometry of another without sharing its internal rules. The result would be an effect without a story, a phenomenon without an explanation that fits inside our framework. We would build models, we would add terms, we would give names. But the origin would remain hidden, not because it is small or far away, but because it belongs to a region that does not speak our physics. This possibility reframes one of the deepest frustrations in cosmology: the feeling that most of the universe is made of things we cannot see, touch, or identify. That ordinary matter is a minority, that the universe's behavior is dominated by unknown components. What if those components are not components at all? What if they are shadows cast by adjacent realities? From this perspective, our universe is not incomplete. It is entangled, not entangled in the quantum sense, but in a structural one. Its large-scale behavior influenced by conditions beyond its own descriptive reach. Shaped by neighbors it cannot observe directly. This would also explain why these influences are so stubborn, why decades of increasingly sensitive detectors have failed to reveal their nature, why they refuse to resolve into familiar forms. We are looking for objects. There may be none. We are looking for particles that behave like particles here. But if the source of the influence does not belong to our zone, it would not manifest as a particle at all. It would manifest as geometry, constraint, bias. From our side, it would always look like something missing, and so we keep naming the absence. There is a quiet shift that happens when you accept this possibility. The universe no longer feels like a closed system with a few unknown variables. It begins to feel like a neighborhood, one district among many, affected by what lies beyond its streets, even if it cannot see them. This does not make the universe hostile. It makes it porous in influence, not in communication, shaped by neighbors it cannot know. And that brings with it a subtle, almost unsettling humility. The recognition that some of the forces shaping our reality may never be accessible to explanation within our own laws. Not because they are mystical, but because they are external. As this thought settles, another realization begins to form. If influence can cross zones without information, if our universe can be shaped by realities it cannot observe, then our picture of causality itself may be incomplete. We assume causes must be local, traceable, and describable. But what if some causes lie forever outside our explanatory reach, leaving only their fingerprints behind? And if that is true, how much of what we call randomness, coincidence, or fundamental mystery is actually the quiet pressure of other regions of reality? Resting just beyond our zone, we imagine a boundary as something you can point to, a place, a line, a moment of crossing. But if zones exist, the boundary may not be spatial in the way we expect. It may not be something you reach by traveling far enough. It may be something you reach by becoming incompatible. The edge of a zone may not lie at the outskirts of the universe. It may lie at the outskirts of applicability. At some point, the rules stop mapping cleanly onto what happens next. From inside the zone, This feels like confusion. From outside, it may feel like clarity, returning just not our kind of clarity. Consider how physics behaves at extremes. As you approach immense gravity, time stretches. As you approach absolute zero, motion fades. As you approach the smallest scales, particles stop behaving like objects and begin behaving like probabilities. These are not failures of reality. They are warnings. Warnings that we are nearing the edges of where familiar descriptions hold. If zones are defined by conditions rather than distance, then crossing into another zone would not require a journey. It would require pushing matter, energy, or information beyond thresholds that our local physics quietly depends on. At that point, the world does not explode. It simply stops responding the way it used to. A reaction yields an outcome that is almost right, but not quite. A conservation law holds in aggregate, but not in detail. A signal arrives, but stripped of the features that made it interpretable. This is the most dangerous kind of boundary, the one that looks like error, because error invites correction. It invites us to tweak assumptions, add mechanisms, and preserve the framework. We do not ask whether the framework itself has expired. Crossing a zone boundary would not feel like entering chaos. It would feel like entering a reality that refuses to be simplified in the ways we are used to. The deep discomfort here is not technical. It is existential. Our sense of reality is built on the idea that explanation converges. That deeper understanding brings fewer principles, not more. That the universe ultimately wants to be reduced. Zones suggest something else. They suggest that explanation may diverge, that deeper reality may branch into multiple, equally valid regimes, that simplicity may be local, not ultimate. From inside a zone, this feels like loss. Loss of unification, loss of closure, loss of the dream that one equation lies beneath everything. But perhaps that dream was always shaped by where we stand. If you live your entire life in a valley, the horizon looks like a circle. You may believe the world ends there. When you climb higher, the circle does not vanish, it expands. More valleys appear, more horizons emerge. Reality may be like that. Not a single edge to cross, but layers of applicability. Each one internally consistent. Each one valid within its range. None of them total. Crossing into another zone, then, is not a victory. It is an unlearning. You must release assumptions that once felt synonymous with truth. You must accept that your most reliable intuitions about order, predictability, even existence, were never guaranteed beyond the environment that shaped them. This is why the universe feels so resistant to ultimate explanation. Not because it is hiding, but because it is plural. Plural in structure, plural in behavior, plural in what it allows to exist. And that pluralism is invisible from the inside. From where we stand, everything looks unified, because the zone is unified. The calm is so complete that it feels fundamental. We confuse the absence of disruption with the presence of necessity, but necessity may not be universal. As this realization settles, the question shifts once more. If crossing a zone means leaving behind the assumptions that made understanding possible, then understanding itself may be bounded, not by intelligence, not by effort, but by compatibility, which leads to a final, unsettling thought for this stretch of the journey. If there are regions of reality we cannot understand without ceasing to be what we are, would crossing into them still count as exploration, or would it be something quieter, stranger, and far more difficult to accept? The realization that some parts of the universe are not meant to be known from here, because knowing them would require becoming something else entirely? We often ask whether life could exist elsewhere in the universe. We picture strange worlds, different chemistries, unfamiliar atmospheres, life that breathes something other than oxygen, swims in liquids other than water, thinks in ways we cannot predict. But beneath those imaginings lies a deeper assumption. That life, whatever its form, still requires the same underlying rules. Time that moves forward, causality that holds, energy that can be stored, transferred, and used, information that can persist long enough to matter. Those assumptions feel generous. They may not be. In a zoned universe, life is not just constrained by chemistry, it is constrained by physics itself. And physics may not be kind everywhere. Our kind of life is exquisitely dependent on stability. Molecular bonds must hold long enough for reactions to proceed. Structures must persist long enough to be selected. Memory must exist long enough for adaptation to mean anything. These are not biological conveniences. They are physical requirements. If a region of reality does not support them, life does not merely struggle there. It never begins. This may be why the universe feels so empty. Not because life is rare in principle, but because the conditions that allow life are not evenly distributed. They cluster in zones where physics is gentle enough to allow complexity without freezing it in place. Life, in this view, is not a universal outcome. It is a regional phenomenon. And even more unsettling is this possibility. Other regions may support forms of organization we would never recognize as life. Not because they are too alien, but because the concepts we use, growth, reproduction, memory, individuality, depend on the way time and causality behave here. In a zone where time loops, what does reproduction mean? In a zone where identity dissolves, what does survival mean? In a zone where information cannot be stored, what does adaptation mean? From our perspective, such regions are lifeless. From their own internal logic, they may be full of patterns that do not persist, full of processes that do not accumulate, full of order that never settles long enough to be noticed. Life, as we define it, may simply be the name we give to organization that persists under our local rules. This reframes a question that quietly shapes our sense of importance. Are we special because life is rare, or because we are adapted to notice only the regions where life can resemble us? If zones exist, then the universe may be teeming with forms of existence that never resemble biology, never build civilizations, never leave artifacts, and never wonder about their place in reality. They do not ask questions, so we never hear from them. Our loneliness may be a measurement artifact. We are not counting all the ways existence can happen. We are counting only the ways it can happen here. This realization carries a subtle humility. It suggests that life is not the goal of the universe, nor its central achievement. It is a side effect of particular conditions holding long enough to matter. And those conditions may be temporary. Zones need not last forever. They may form, persist, and dissolve as the universe evolves. A region calm enough to host stars and life today may become inhospitable tomorrow, not through catastrophe, but through slow drift. Constants may shift. Expansion may accelerate. Structures may thin. From inside the zone, this would not feel like an ending. It would feel like increasing difficulty. Reactions would become less reliable. Systems would require more energy to maintain. Complexity would become harder to sustain. Life would not be wiped out. It would be outcompeted by simplicity. This is not extinction as we imagine it. It is obsolescence, and that introduces a quiet, sobering thought. If life depends on zones, and zones are finite, then life itself may be temporary not just in time, but in applicability. We may exist not because the universe favors life, but because we occupy a brief interval where physics allows it. And as that thought settles, another question begins to emerge, one that shifts from what life is to what intelligence does. If intelligence arises only in certain zones, and if those zones naturally hide their own boundaries, what does intelligence do when it reaches the edge of what it was built to understand? Does it adapt, or does it mistake the limits of its environment for the limits of reality itself? Intelligence feels like an escape mechanism. We like to believe that once a species can think, it is no longer bound by its environment. That intelligence rises above conditions, abstracts away limitations, and reaches truths that apply everywhere. But intelligence does not float free of reality. It is shaped by it. Every way of thinking you possess was trained by feedback from this zone. Patterns that repeated, outcomes that mattered, mistakes that killed, successes that endured. Your brain did not evolve to model reality in general. It evolved to compress this reality efficiently enough to survive inside it. That compression feels like understanding, but compression always discards information. Intelligence is not a mirror. It is a filter. It preserves what matters locally and ignores what does not. In a stable zone, that strategy works beautifully. The same causes produce the same effects. The same rules reward the same behaviors. Learning compounds instead of resetting. From inside such a zone, intelligence feels powerful. From outside, it may feel brittle. If a different region of reality rewards different patterns, if causality behaves differently, if time does not accumulate cleanly, if information does not persist, then the strategies that define intelligence here may not function at all. Not because they are incorrect, but because they are misaligned. This suggests a disturbing possibility. Intelligence itself may be zone-specific. Not intelligence as raw capacity, but intelligence as a way of organizing experience, as a set of expectations about how reality responds when probed, as a confidence that effort produces cumulative insight. Those expectations are not universal. In a region where rules drift, where regularities dissolve before they can be learned, intelligence might never stabilize. Not because minds cannot form, but because learning cannot accumulate. Each observation would invalidate the last. Memory would lose predictive power. Understanding would not converge. From our perspective, such a region would appear unintelligent. From within, it might appear inevitable. Our intelligence thrives because the universe here remembers what it did before, because patterns repeat, because explanations stay relevant long enough to be useful. We rarely acknowledge how generous that is. This also reframes a familiar frustration, the sense that some questions remain permanently out of reach, that no matter how advanced our theories become, certain aspects of reality resist clarity. That explanations grow more abstract without feeling more illuminating. We interpret this as a limitation of technology or imagination. It may be a limitation of alignment. We are asking questions that make sense here, in a region where answers behave. Beyond that, the questions themselves may stop fitting the structure of reality, and intelligence, as we practice it, may not know how to adapt. This is the trap of success. The better intelligence works locally, the more it trusts its own methods. The more it trusts them, the harder it becomes to abandon them. The more difficult it becomes to recognize when the environment has changed. An intelligence optimized for one zone may misinterpret another. It may see randomness where there is structure. It may see contradiction where there is coherence. It may see impossibility where there is simply difference. This does not make intelligence useless. It makes it contextual. Our minds are astonishing tools for navigating this version of reality. They are not guaranteed to be keys to all versions, and that realization carries a quiet humility. It suggests that the universe does not owe us comprehensibility. That understanding is something that happens under certain conditions, not a right granted by thinking itself. If zones exist, then intelligence may bloom in pockets and wither elsewhere. It may reach incredible heights in regions like ours, then quietly fail to generalize beyond them. Not through error, through mismatch. This also changes how we think about progress. We imagine intelligence steadily approaching a final understanding, peeling back layers until nothing remains hidden. But what if intelligence, instead, approaches a boundary, a point where its methods lose traction? Not because the universe is deeper, but because it is different. At that point, intelligence would face a choice. It could cling to its frameworks, insisting that reality must conform, or it could accept that understanding itself has a domain. That acceptance would not feel like enlightenment. It would feel like loss, the loss of the belief that thinking hard enough guarantees access to truth everywhere. And as this thought settles, another question quietly emerges, one that feels almost too personal to ignore. If our intelligence is adapted to this zone, and if this zone is only one version of reality, then what happens to meaning, purpose, and value when you realize that they, too, may be local constructs? Do they dissolve, or do they become more fragile, and therefore more precious? When something refuses to fit our understanding, we call it broken. A theory fails. An experiment disagrees. A phenomenon resists explanation. Our instinct is to fix it. We assume that reality is supposed to line up with our expectations, and when it does not, something must have gone wrong either with the data or with the universe itself. But that instinct comes from living inside a zone where coherence is the norm. In a zoned universe, difference does not imply defect. Other regions would not feel chaotic from within themselves. They would have their own regularities, their own balances, their own forms of stability. They would not experience themselves as broken versions of our reality. They would experience themselves as complete. It is only from here that they would look wrong. This is an uncomfortable shift in perspective. It suggests that when physics elsewhere diverges from ours, it is not violating universal law. It is expressing a different one, a law that does not translate cleanly into our language, not because it is irrational, but because it is built on different foundations. We are used to thinking of reality as one thing that can be progressively understood. Zones suggest something closer to ecology. Different environments, different rules of survival, different patterns that make sense locally and fail globally. In that view, our physics is not wrong. It is provincial, and provincial knowledge can be extraordinarily powerful without being universal. A deep understanding of one ecosystem does not automatically confer understanding of all ecosystems. Expertise is always contextual, even when it feels fundamental. This reframing softens a fear we rarely articulate. The fear that if the universe is not fully understandable by us, then something has gone terribly wrong. Zones offer a gentler explanation. Nothing is wrong. We are simply not everywhere. Reality does not owe us comprehensibility across all its forms. It only needs to be coherent where coherence is possible. From this perspective, the universe becomes less like a puzzle designed to be solved and more like a landscape to be inhabited. Understanding becomes something you cultivate locally, not something you conquer globally. This has a subtle emotional effect. It replaces frustration with humility. It replaces urgency with patience. It replaces the demand for final answers with respect for boundaries. We often imagine that if we fail to understand something, we have failed as thinkers. But perhaps the deeper failure is assuming that understanding must always be possible from our position. If zones exist, then there may be regions of reality that are perfectly lawful, perfectly structured, and permanently inaccessible to our way of knowing. Not hidden, not forbidden, simply incompatible. And that incompatibility does not diminish them. It only defines us. This also changes how we think about mystery. Mystery is no longer a temporary gap in knowledge waiting to be closed. It may be a permanent feature of perspective, a reminder that reality exceeds any single vantage point. From inside our zone, mystery feels like an insult to reason. From a broader view, it may be the natural result of plurality. The universe may not be one story told everywhere the same way. It may be many stories happening at once, overlapping only partially, each internally consistent, none of them total. Our mistake is not that we tell one story. It is that we believe it is the only one. As this thought settles, the sense of conflict begins to soften. The universe no longer feels adversarial, withholding answers. It feels expansive, layered, and quietly unconcerned with being fully known by any single observer. And that leaves us with a question that feels less scientific and more reflective. If the universe is not broken beyond our zone, if it is simply different, then what does that make our search for truth? Is it a quest for universal laws, or a deepening intimacy with the particular place where we find ourselves? And if it is the latter, how should that change the way we listen, explore, and imagine what lies beyond the edges of our understanding? From a distance, the universe looks unified. Galaxies follow similar patterns. Light behaves consistently. The same equations seem to work across unimaginable scales. From where we stand, everything appears stitched together into a single, coherent whole. This impression is powerful. It invites us to believe that reality is fundamentally one thing, governed by one set of rules, unfolding everywhere in the same way. Diversity exists, we say, but only in content, not in structure. Zones quietly undo that picture. They suggest that what looks unified from inside may be plural from outside. That coherence may not be global, but regional. That reality may not be a monolith, but a mosaic, a patchwork, each piece internally consistent, each piece stable in its own way, each piece touching others without becoming them. From within one patch, the seams are invisible. You do not see borders when you live far from them. You see continuity, repetition, reliability. You see laws that hold and patterns that endure. You build stories of universality because nothing challenges them. But from a broader perspective, one we may never fully access, the universe could look very different. Not like a single narrative, but like overlapping regimes. Regions where space behaves one way, time another, causality another still. Not contradictions, coexistence. This is a difficult idea to hold because it resists closure. There is no final equation that unifies all zones. No master framework that collapses diversity into simplicity. Instead, there is structure layered upon structure, each one valid within its range. From our zone, this feels unsatisfying. We want foundations. We want bedrock. We want something that does not depend on where you stand. But dependence on where you stand may be the deepest truth of all. If reality is patchwork, then understanding is positional. Knowledge always comes from somewhere. Perspective is not a flaw, it is a condition. You cannot see everything at once because everything is not one thing. This reframes what it means to return from the edge of understanding. We do not return with answers that dissolve mystery. We return with a different relationship to it. A recognition that mystery is not a temporary gap, but a structural feature of existing inside one region of a larger whole. From this view, our science has not failed to reach universality. It has succeeded at something more modest and more profound. It has mapped our patch, with extraordinary care, with astonishing precision, with enough depth to let us build civilizations, ask questions, and imagine what lies beyond. That is not trivial. It is rare, and it may be all that is ever available from here. Zones do not diminish the value of understanding. They localize it. They remind us that knowing is always an act that happens somewhere, under some conditions, with some limitations, and those limitations are not obstacles to be overcome. They are part of the shape of knowing itself. As this realization settles, something shifts quietly. The universe no longer feels like a riddle designed to frustrate us. It feels like a vast terrain where different kinds of order arise, persist, and fade, sometimes touching, sometimes influencing one another, rarely aligning perfectly. We are not at the center of that terrain. We are on one of its calm plateaus. And from here, the question is no longer whether our laws apply everywhere. The question becomes gentler. What does it mean to live well inside a patch of reality? Knowing that it is not the whole, how should curiosity behave when it accepts its own position? And how does wonder change when it no longer demands universality, but learns to listen carefully to the quiet, local truths that made listening possible in the first place? Those questions do not ask to be answered. They ask to be held. As the universe continues to unfold, differently, elsewhere, while remaining just stable enough here for you to be listening now. If physics works only here, then this place is not the universe. It is a neighborhood, a region where reality happens to behave in ways that allow memory, continuity, and thought. A pocket where causes line up neatly enough to be traced, where time flows gently enough to be felt, where light carries stories instead of erasing them. From inside this neighborhood, everything feels fundamental, but nothing here had to be. This realization does not arrive like a revelation. It arrives quietly, like a cooling room after a long day. Nothing collapses, nothing shatters. The laws you trust still work. Gravity still pulls, time still passes, light still reaches you from distant stars. What changes is not reality. What changes is the story you tell about it. You no longer imagine the universe as a single, unified machine humming with perfect consistency from edge to edge. You imagine it as a vast expanse where different kinds of order arise in different places, for different lengths of time, under different conditions. Some regions allow observers. Some allow structure without awareness. Some may allow nothing that lasts long enough to be named. And none of these regions are wrong. They are simply not interchangeable. From this perspective, our existence stops feeling like a cosmic accident and starts feeling like a local inevitability. If a region remains calm long enough, something will eventually notice that calm. Not because the universe intended it, but because noticing is what calm permits. We did not appear because reality wanted to be understood. Reality became understandable here, and so understanding appeared. This does something subtle to meaning. Meaning no longer has to be universal to be real. It does not need to apply everywhere, forever, to matter. It only needs to arise where experience can hold on to it. In a zoned universe, meaning is not written into the cosmos. It is cultivated here. By being shaped by this place, using concepts that work here, asking questions that make sense here, and mistaking those questions briefly, understandably, for the questions of all existence. There is no shame in that mistake. It is how intelligence feels from the inside. What matters is what happens after the mistake loosens its grip. Curiosity becomes quieter. Certainty becomes softer. Wonder becomes less demanding. You no longer ask the universe to justify itself in your language. You listen for what this place is saying, without insisting that it speak for everywhere else. The silence beyond your reach stops feeling like emptiness. It starts to feel like difference you were never meant to translate. And that difference does not threaten what you know. It frames it. If physics works only here, then here is extraordinary. Not because it is central, but because it is gentle. Gentle enough to allow continuity. Gentle enough to allow memory. Gentle enough to allow a moment like this, where thought can slow down and notice that it exists at all. Close your eyes now, and imagine the universe not as one thing, but as many realities unfolding side by side. Some loud, some brief, some utterly silent, some so different that no signal could ever cross between them. And imagine this place, this narrow region where laws feel stable, where questions make sense, where stories can be told floating among them, unremarkable from the outside, precious only from within. The universe does not owe us universality. It has given us something rarer, a place where listening is possible. And while the rest of reality may be unfolding in ways we will never understand, this small, calm patch continues to hold together quietly, temporarily long enough for you to be here now, breathing, thinking, and wondering what else might exist beyond the edges of what works. Here,